long before we moved into the cities and polluted our skies, we shared a special connection with the stars. It was the movement of stars across the sky that allowed us to have a definition of time itself. Our navigators used stars in order to find the directions. Our farmers used stars in order to predict the season, which in turn allowed them to make several decisions about when to till the soil and when to expect the harvest. But in today's day and age, with all our technology and information available at the touch of a button, we no longer need astronomy to answer these questions. So, we need to ask the question explicitly, how to become an astronomer. And this video is all about answering that question. So the way we'll proceed is as follows. We will first define what astronomy is and what it isn't, and why we should study astronomy. And then I will give you two ways by which you can pursue a study of astronomy, what we call amateur astronomy and professional astronomy. I'll give you details which will help you get started on your journey to becoming an amateur astronomer right away. And as far as the journey for becoming a professional astronomer, it's a very long journey, and I'll also give you details about that. So what is astronomy? Astronomy is the study of celestial objects, the space in which they exist, and the universe as a whole. So in astronomy, we try to make measurements of the properties of various celestial objects and try to understand them better. I was once having a conversation with a group of people, and one of the members of that group decided to ask me a very common but irritating question. They asked me, can you use your knowledge of astronomy to predict my future? And I immediately understood that they are confusing astronomy with astrology. It is very important to understand that in today's day and age, these two words mean entirely different things. Once upon a time, several thousand years ago, astronomy and astrology were essentially the same. But in today's day and age, you have to differentiate it between these two terms. In astronomy, we are paying attention to the science of the celestial objects. In astrology, people are trying to use the patterns in the sky in order to predict the fate of individuals or a collection of individuals. Okay? But it is important to note that astrology is not a science. I'm going to make a separate video about why astrology cannot be considered as a science, but for now it is enough that you understand that astronomy is not equal to astrology, and astronomy is a science and astrology is not a science. The other important word that often arises when discussing astronomy is the word astrophysics. So what exactly is astrophysics? Well, physics is the branch of science that deals with the fundamental laws of nature. An attempt to apply these laws of nature to try and understand celestial objects in great detail is known as astrophysics. Now, you can very casually call an astrophysicist an astronomer or vice versa. They'll not take offense. The dividing line between astronomy and astrophysics is very thin, and they are actually used interchangeably very often. But it's good to know a subtle difference between the two. When you're paying more attention to the physics of these objects, you're doing astrophysics. But when you're paying attention to measurement of properties as a whole, you are doing more astronomy. But it's a very loose distinction. The dividing line is very thin. So remember that. Now, why would you study astronomy in today's day and age, where you no longer need stars to measure time, you no longer need stars to predict seasons, you no longer need stars to navigate ships? So why would you study astronomy in today's day and age? Well, you study it because you want to study it. That's all. Because it is fun. So the primary reason you would want to study astronomy is because you enjoy studying astronomy. And the other reason, of course, is a more general reason, that the pursuit of any knowledge is not wasted. So how can you become an astronomer? Well, there are two broad approaches that you can take. One is called amateur astronomy. So this is where you study astronomy as a hobby, right? There are no commitments. You continue with your existing education or professional commitments, and whenever you get time, you try and study astronomy. This is the most straightforward way to become an astronomer, and it is recommended for most people. The second approach is professional astronomy. So this is where astronomy is your profession. You get paid to do astronomy. And before you decide, hey, that's a cool job, I want it, stick around to the end of this video so that you understand how long that journey can take before you can become someone who gets paid to do astronomy. So let's see how we can get started with amateur astronomy. So the first basic step is to just go and watch the skies. Yes, that's it. Just go to the top of the roof of your house or some clear space where you can clearly watch the skies. Hopefully the skies are not cloudy. So you'll see some stars in the sky. Maybe you'll see planets. You'll see the moon. See what kind of patterns are there and ask the question, are these patterns systematic? Are they changing with time or not? And that's it. You have begun your journey as an astronomer. And one thing that you can do in order to help understand what these stars are and what are these patterns known as constellations, you can use an app known as the Google Sky Map. So the Google Sky Map looks something like this. So it basically shows you basically point it to any part of the sky, and it uses the knowledge of it uses the sensors in your cell phone and the time of the day in order to predict what stars will be there at a given point in the sky. So using this simple application, you can get started with amateur astronomy, and that's it. Your journey has begun. So it's not just enough to actually look at the stars. You also want to understand more about them. So start, after a couple of observations, what you can do is start using your favorite search engine for various sources on astronomy. Like search for words like positional astronomy, coordinate systems, and so on. And try expanding your knowledge. A very fun way of expanding your knowledge is to watch good documentaries. And my personal favorites for the documentaries are the 3 Cosmos series, the original Cosmos, A Personal Voyage by Carl Sagan. Then there is Cosmos, A Space Odyssey, and Cosmos, Possible Worlds, hosted by Neil deGrasse Tyson. These are worth watching for any astronomy or science enthusiast. I am personally not recommending any books because there are plenty of books out there. And which book will you like depends on where you are, how much do you understand about physics already, etc. So I'm not really going to recommend books here, but a simple search engine will help you get hold of all the resources that you need in order to learn about all the topics related to astronomy. Now, it's not just enough to try and read things off the internet or using books. It's always good to have some personal help so that you can learn more rapidly. So one of the first things that you can start doing is to inquire about various planetaria or research institutes in your city and see what kind of programs they organize. Just see if there is a research institute which has an outreach program where they organize regular talks or lectures which you can attend to not only expand your knowledge but more importantly meet like-minded people so that you can work together and try and understand various aspects of astronomy much faster. The next obvious thing to do is to form a group of amateur astronomers or join an existing club that might be in your city. Now, some of the activities that clubs, astronomy clubs undertake would include basic lectures or workshops. So, for example, there might be workshops that teach you how to make your own telescope. And there might be stargazing parties. These are really fun events. So what people generally do is a group of 20, 25, 40 people can hire a transport and go in the outskirts of the city where there is less pollution and the skies are clear, and they observe the skies together. A major advantage of being a part of such a sky gazing event is that a lot of volunteers who already have telescopes bring their telescopes to this event and allow people who are just getting started to see the glory of the sky through the telescope. So definitely go and search for amateur astronomy groups around you and try and participate in their events. Now, the way your eye works is that there is the pupil. It collects the light and it's converted into signals that your brain interprets as images, right? Now, how much light does it collect is what determines how faint an object can our eye see. So imagine the eye as a bucket, right? So if the bucket is small and it is raining, it's going to collect a certain amount of water. If the bucket is bigger, it's going to collect an even larger amount of water. So if your eye is like a bucket, then you need a larger eye in order to collect more light, and the more light you can collect, the fainter objects will become accessible to you. And that is why we go beyond the eye and use instruments such as telescopes. So one of the first big steps that you could take in your pursuit of amateur astronomy is to buy an extension to the eye. So a simple thing and very affordable thing to buy would be the binocular. Even with the binocular, trust me, there are a lot of things that become clear and visible. I remember that when with my bare eyes, I could see something like a fuzzy spot in the sky. I never realized that there were 7 distinct stars until I saw through my first binoculars. So it's a very exciting revelation to even watch certain parts of the sky with just a binocular. And the next step, of course, is to buy a telescope. The telescope is far superior to the binocular in terms of its light gathering ability. And here too, you have many options. You can start with a simple handheld telescope that would be very cheap. Then the next more expensive option would be to have a large telescope which you put on a tripod so that you don't have to carry the weight and it is stable, so that you can point to a specific part of the sky and observe it for a long time and not get affected by shakes. The third level of a telescope would be where there is a motor attached to the telescope which slowly rotates the telescope to take into account the Earth's rotation, so that if your telescope is pointing to a specific part of the sky, it will continue to point to that specific part. Else what would happen is that the Earth rotates and a new part of the sky comes in your telescope. But by rotating the telescope along with the Earth, you can actually continue to point to the same region in the sky, which is why you have motorized telescopes. And then you have the next level, which is motorized telescopes, but with a computer attached to it, which actually gives you an interface using which you can actually instruct your telescope to point to a particular region in the sky. And that is the most advanced telescope that an amateur astronomer can buy from some company and continue working in the field of amateur astronomy. The next thing that you can do is indulge in astrophotography. So once you have access to a telescope with a mount, what you could do is attach your DSLR camera at the back of your telescope using a suitable adapter and actually take photographs of the sky. So you no longer have to keep a memory of what you see in your brain. You can photograph it instead. But astrophotography is challenging because normal cameras are designed to take photos around you where there is plenty of light. But there is very little light available to us when looking at astronomical objects. And so the images actually tend to be noisy. So to get really good photographs, you also have to invest some time in understanding how to edit the photograph to remove that noise. The other thing that people often do is to take multiple photographs of the same object and then stack these images together. So what happens is you take several images and then you combine them to give one image, which actually looks better than all the other images. So this is called stacking, and there are a lot of amateur astronomers who have learned how to do this stacking of images and produce some wonderful photographs. So astrophotography is definitely one important activity that a lot of amateur astronomers like to indulge in. Now, whether you are a school student or a working professional, it doesn't matter. One of the things that you should definitely try for fun is to participate in what are called citizen science projects. So what exactly is a citizen science project? Well, let's say I'm a scientist and I have used a modern robotized telescope to make observations of the sky. And I have made images of millions and millions of galaxies. And I would like to sort these images or classify these images in various groups. For example, some galaxies contain what are called bar structures, some galaxies contain spiral structures, etc. I would like to sort my galaxies into these categories, whether they have a spiral arm or not. But there are millions of objects and I simply do not have time to go through it. So what I can do is I can start a citizen science project. What happens in a citizen science project is that I make a website, you come and register on that website, and I give you my images and I ask you various questions. You answer these questions, and by collecting answers from a lot of people around the world, I suddenly have a lot of data using which I can easily sort my galaxy images into various groups. And that is what citizen science is all about, taking help of non-scientists or citizens to help scientists in their research. So there is this website called zooniverse.org. You can see the link on the screen. There are many, many citizen science projects that you can start participating in right away. Some of the projects in astronomy include the example that I just gave you, where you classify galaxies, but you can also search for planets that go around other stars. You can also catch what are called transient objects, that is, objects which are changing with time. The ultimate thing that you can do in amateur astronomy, which is in fact something that will take you very close to being a professional astronomer, is to start making measurements. So in astrophotography, for example, we are only taking good images and sharing them with our relatives and friends and peers and getting comments. But if you have access to a photometer, which basically captures light and converts it into electricity, and then by measuring the electricity, you can comment on how much light had fallen on the instrument. Or you can take a CCD, right? And you can even put some filters that are colored glasses in front of these CCDs, and you can actually measure the brightnesses of these objects. And that is not an easy task, right? So there are a lot of techniques that are needed in order to measure the brightness of these objects. And even after applying these techniques, the brightness that you measure may not be the correct brightness. because you see certain amount of light has been eaten away by the sky that is between me and the telescope. Sorry, between the telescope and the object. Whatever sky is present, it is eating away some light, and that is going to change the measurement of your brightness. So there are a lot of things that need to be accounted for when arriving at a final measurement. And this is a very advanced process, but there are plenty of amateur astronomers who slowly have reached a stage where they are able to do these measurements. You can be one of them, but that takes a lot of time and patience. And that's why I consider it as the ultimate in amateur astronomy. There are in fact databases that have been constructed by groups of amateur astronomers, which are actually used by professional researchers for understanding about some object. So they basically go and look at this database to see if some amateur astronomers have contributed high quality measurements for these objects. So this is really sort of at the boundary between amateur astronomy and professional astronomy. It's one of the most satisfying things that you can do as an amateur astronomer. All right, so now it is time to answer the question, how do you become a professional astronomer? So just to remind you, a professional astronomer does astronomy as a profession. So we are going to assume for now that a professional astronomer means an academic researcher who is affiliated with some university or some institute of research and does astronomical research. So how do you reach there? What are the last two stages that you need to go through to become a full-fledged professional astronomy researcher? Then I will tell you how to reach these last two stages. So let me start with the last two stages first. So the second last stage is doing a PhD. Okay, so what happens in a PhD is that you choose a narrow area of research, you do a couple of courses, then you do intensive research in this area, and then you publish your research, you publish a thesis and you defend it. And if you do a good job, you are awarded a PhD and you can prefix doctor before your name. For example, after my PhD, I stopped being Mr. Kaustubh and became Dr. Kaustubh. So then what you do is do something called postdoctoral research. So as the word implies, postdoctoral, meaning after PhD. So the idea is that while you were doing your PhD, there was your PhD supervisor who was sort of hand-holding you and guiding you through the research. But if you are given a professorship, you will have to be an independent researcher, not dependent on anyone. You will also have to learn how to guide students. So it is generally considered that a person who has just finished PhD is not ready for a professorship. So what they do is go and do postdoctoral fellowships. So the number of years that you spend on postdoctoral fellowship can vary. Typically it's 3 to 4, can be as high as 6 to 7. Some people go up to 10 even. But the basic idea of postdoctoral research is to go to some other institute, work with a different group, and demonstrate your capability of doing independent research by publishing research papers, etc. And then you become eligible to be a professor at either a university or a college or an institute which has a department for astronomy research. So what exactly do you do when you become a professor in astronomy? Well, the obvious first thing you do is teach. So you'll be providing a variety of courses in various topics in astronomy. You'll be teaching students at master's level, at PhD level, etc. And you'll be doing your own independent research. You will also have PhD students whom you will be responsible for helping them complete their PhD. and you will also be doing some community services. Astronomy outreach or public outreach should be one of them. So a professor will also contribute in educating people about astronomy. They can do it at small scale by giving lectures in local colleges, or they can do it on very large scales by having their own YouTube channels or running online courses, etc. And they can also participate in various governing bodies which are generally aimed at trying to develop the education system of a country or a town or a city or whatever level the committee works on. So these are typically some of the things that professors in astronomy are going to do throughout their lives. Okay, so you know how to become a professor in astronomy so that you can do professional astronomy full time. So it involves a PhD and it involves a postdoc or a couple of postdocs rather. Now the question is, how do you prepare to get into a PhD program? So you can be at various stages in your education, and based on that there are things that you can do to prepare for getting into a PhD program. So let's start with the lowest rung of the ladder. What if you are a junior school student? Well, it is too early to actually start preparing or thinking about your PhD. But what you should definitely do is indulge in amateur astronomy. Start meeting people, start attending lectures meant for school kids. Join astronomy clubs, but not at the cost of your studies. Your school studies are very, very important. Do not neglect your school studies just because you are passionate about astronomy. So what if you are a high school student? Well, if you are a high school student, you have to now prepare to narrow down your focus. So typically after you leave school, you have to choose which subjects you want to major in. And mathematics and physics should be your prime focus. Here is a fun factoid. Whenever you give examinations or interviews in order to get selected for a PhD program in astrophysics or astronomy, they never ask you a question on astronomy and astrophysics, which is a little interesting, isn't it? Well, that's because in order to do astronomy and astrophysics properly, your knowledge of mathematics and physics should be very sound. And that is why it is very important that you don't get tempted to start rushing towards things, picking up advanced books on astrophysics and studying them. You don't need to do that. You can do it for fun, but you should not do it at the cost of your knowledge of maths and physics. Every obscure topic that you feel is like, why am I studying this? Can become very, very important in the future. So here is a fun factoid. A lot of students learn something called quantum tunneling, right? Quantum tunneling is actually responsible for yours and my existence, for the existence of this entire universe. Why? Well, I leave you to find out about that. But once again, coming back to the topic, if you are a high school student, you have to narrow down your focus towards mathematics and physics to prepare for your junior college. And remember that it's your knowledge of maths and physics that is going to get you through into a good PhD program. So don't again get tempted to start studying advanced astrophysics texts, even if you can. What if you are a junior college student? Well, students from India will immediately understand what junior college means, but for those from other countries who may not know what junior college is, because that's not how you call it, it just refers to an year or two before you take up your bachelor's courses, where you have sort of given up a few subjects and narrowed down on subjects that you believe are going to help with your next stage of the career. So in this case, junior college students would ideally have taken maths and physics as two important subjects to study. And this phase should be utilized in researching and finding out what colleges offer good programs for doing bachelor's in pure physics. You should find out what colleges or institutes or universities are offering bachelor's programs. You should try and contact some students who are already there, and you should chart a strategy for how you will get selected for your favorite college. What if you are a bachelor's student in pure physics? The most important thing you should do is solve as many numerical problems as you can. Because it might happen that a lot of teachers ask you to derive some equation, and if you are able to derive an equation, you are given full marks. But no entrance examination is ever going to ask you to derive an equation. What they are going to do is ask you to largely solve numerical problems. Therefore, your focus should be on upgrading your ability to solve numerical problems. The bachelor's course that you are enrolled in may stop at this level. You have to go much above and beyond the curriculum in order to truly be prepared for getting into good master's programs. In summer vacations, for some research institutes offer special vacation programs for bachelor students. So do keep an eye out for such opportunities to intern or to attend a special course or a project at various research institutes and try to be a part of that. You get some very early exposure to research methodologies. And of course, you have to scout for good colleges or institutes which offer a good master's program, and do the same thing. Try to get in touch with people who have already gone into these colleges, find out how to prepare for the examinations, and try to form a group of peers so that you're not alone in this very hard exercise of preparing for examinations. So what if you're a master's student in pure physics? Well, you should devote a considerable amount of time to understand what kind of PhD programs are out there, what do they require from you, how do you get enrolled in these programs, and what are the examinations that you need to crack or tackle. So this is going to be a very important preoccupation during your master's life. And of course, you have to pay complete attention to all the subjects that you're studying. Preparation is the key. And at master's level, you will definitely have access to more programs and opportunities where you can spend a summer or a winter at a research institute. So definitely try to be on the lookout for such opportunities and do not miss them. Now, a very important thing to remember is that most research institutes don't give an examination and purely select based on that. Apart from an examination, they also interview the candidates. And this might be something new to you. So one of the things you should definitely prepare for is to face a panel of very senior researchers, and they will ask you questions on fundamental mathematics and physics, and you have to answer them. So you have to practice for this, especially if the dream institute that you want to get in believes in interviewing their candidates before making an offer. What if you are an engineering student and have decided that you would like to do a PhD in astronomy? Well, similar rules apply. You should research on what kind of PhD programs are out there, and you have to very carefully go through the eligibility criteria. Some PhD programs insist that you have a master's in pure physics. Some research institutes are okay in letting engineering students directly come to the program. Some research institutes demand that engineering students undergo some coursework before they can actually take up their PhD research. So depending on the PhD offering institute, whether you can enter their PhD program or not, and if yes, what are the conditions you will have to satisfy, will change from institute to institute. So research on this very carefully and start preparing in advance. Now, typically, the amount of physics that is taught to engineers is very limited, and this physics is not sufficient enough to tackle entrance examinations or interviews, and so you have to do extra hard work to try and catch up with all the physics that you missed by not being in a bachelor's degree program in pure physics. Let's say that you are selecting a college for your bachelor's program or your master's program. One of the things that can help you in making this choice is either some publication by an accreditation agency or some other list which ranks the colleges according to good or bad or whatever criteria they use. Which means that if you want to decide whether college A is better than college B, there is a ranking list that can help you make that decision or answer that question. But that is not true with PhD. Because a PhD has three essential ingredients: your PhD supervisor, the topic of your research, and the publications that you will have to produce in order to get your PhD. Now, let us suppose that you want to work in the field of solar physics, which is a narrow branch of astronomy specifically focusing on the sun. And let's say that somebody tells you that certain college X is the best for astronomy, whatever that means. But there is not a single faculty in college X who is researching in solar physics. So what do? Your PhD will become hard, if not impossible, when you don't have a researcher in an active area of what you want to work in. So it is very important that you pay more attention to who your guide will be and where does that guide work, rather than the reputation of the place where the guide works. So it's very, very important. Also, the relationship with your PhD supervisor is a long-term relationship. So you need to consider that when making the decision. So remember that a good PhD supervisor, and good is in quotes, there is no absolute good here. It is good according to you. And what that means is that the supervisor is working in an area of research that you want to work on. The supervisor has characteristics or qualities which makes it easy for you to get along with the PhD supervisor. And the PhD supervisor also has good collaborations so that you can get an extended contact list of people to rely on during your research phase. So these are all much more important things than the exact place where you will end up working for your PhD. But in general, there is a positive relationship between the reputation of the place and reputation of the researcher. Good researchers tend to generally work in higher ranking institutions. So if you have selected the best in a particular field as your potential PhD supervisor, chances are that you also have selected a good place or a place of good repute automatically. But that being said, one should always remember that the institute's reputation is less important than what the guide can potentially offer you should you choose then as a PhD supervisor. Okay, so that basically is what I wanted to cover as a big elaborate answer to the question how to become an astronomer. But before I end, for those of you who wish to embark on this very long journey of becoming professional astronomers, please remember to have a plan B. It is very important to have a plan B. Firstly, the journey is very long. Secondly, life happens during this journey. You graduate from college. You are a bachelor who thinks he can spend time doing only research. But eventually, all kinds of things happen. Your family is growing old. You get married. And there are several other things that happen, which can completely change your life, add a set of restrictions, etc. So you should be very careful about having an alternate plan when you go on this very long journey. You should also remember what I call the pyramid of opportunities. At PhD level, you have many opportunities. Then you start searching for postdocs, there are lesser opportunities. And after postdoc, when you want to search for a faculty position, the opportunities are even lesser. So that's what I refer to as the pyramid of opportunities. So not everyone with a PhD, even from the best institute, is going to wind up being a professor or a full-time researcher. So please remember that. There are other important things to take into account. For example, financials. Not tremendous amount of money can be earned through this path. So the 10 years you will spend in trying to construct a career in astrophysics, your friends who immediately join, say, industry positions right after your bachelor's or master's, wherever your paths diverge, financially they will grow much faster. And this is something that you will always hear. You're still not finished your PhD and some of your friends would have gotten married, they would have kids, they would be having their own houses, investments. Many of these things will not be available to you. So there are potential sacrifices to be made when going on this journey. So please do keep it in mind. I personally don't believe in encouraging people to take up a career without giving clarity on what lies ahead. So it is not meant to discourage someone from pursuing a career here, but it is to remind them that it is a very long path and a lot of things can change along this path. So I hope this video was helpful to you in finding your own answer to the question, how to become an astronomer. There are several things that I could have covered more, but for now, I think this is enough material for people to consume. And if there are questions in your mind, please do leave them in the comments below. And I will try my best to either answer as a reply to your comment, or maybe I can take a collection of several questions and make a new video where I only answer questions posted by you. Thank you so much, and all the best in your journey to become an astronomer. Thank you.